AOC. Extreme C, L, O, S, I, U, P, O, N, Restab iOS Salt casos glinting that this is a murder scene. Not with a weapon, but with saltwater. This 1978 Harley Davidson Sportster was left to die by the ocean for 15 years. Every bolt is frozen, every wire is dust, and the engine is a solid block of rust. The question isn't just, can we bring it back? But should we even try? What happens when you pit modern restoration techniques against one of nature's most destructive forces? This is the story of reversing chemical murder. Presentation. Wide shot OFT at the e-bike garage, surrounded BYD EGREASERS and tools meet the victim. A 1978 Harley Davidson Sportster XLH mill. The Ironhead engine was legendary for its power and its temperament. But saltwater doesn't care about legend. It's eaten through the chrome, seized the crankshaft, and turned the cylinder heads into Swiss cheese. Our mission: perform a mechanical autopsy, reverse 15 years of corrosion, and make this American icon roar again. This isn't a polish job. This is a resurrection. We're dealing with chloride ions that have penetrated deep into the aluminum and steel, creating galvanic corrosion that's far worse than freshwater damage. The salt has essentially created tiny batteries within the metal, eating it from the inside out. Dismantling TAAK corrosion. POV shot using impact dwarcench on furrows and bolts problem. Salt acts as a welding agent. Every nut and bolt is chemically fused through a process called crevice corrosion. The sodium chloride has reacted with the metal to form iron oxide hydroxides, rust, but also aluminum oxide on the engine cases. These compounds expand, locking threads permanently. Solution. We start with a specialized penetrating oil formulated for marine corrosion, applied daily for a week. Then, strategic heat application using an induction heater to expand the outer component without damaging what's inside. For the most stubborn fasteners, the hydraulic press applies controlled force. The primary goal isn't speed, it's preservation. We need to extract critical components like the drive chain, primary cover, and transmission sprocket without destroying their mounting points. Each fastener represents a trinta minute to do our battle. Visual transformation. The bike is slowly stripped down to its skeleton. Piles of corroded parts grow on the bench, each telling a story of neglect. The frame, once hidden under layers of grime and surface rust, reveals its true condition. Deep pitting in the steering head and swing arm pivot areas. Anticipation. But the real challenge is still hidden inside the engine cases. The external corrosion is just the visible symptom. The internal damage could be terminal. AE engine autopsy. CROSSSECTION VWOF engine block with BORESCOPE problem. The heart is silent. Saltwater infiltrated past the piston rings, rusting the pistons to the cylinder walls in a chemical weld. The crankshaft bearings are likely fused to their races. The cam chest is probably a solid block of corrosion. Solution. Methodical disassembly begins. The cylinder heads come off first, revealing the horror inside. We use a high-resolution borescopy to inspect the cylinder walls for deep scoring beyond the standard overbore limits. The crankshaft is checked for runout with a dial indicator. Any bend over 0. Trace inches means it needs regrinding or replacement. This step is critical. A crack at engine case or transmission housing means game over, as finding replacements for a 1978 Ironhead is difficult and expensive. Visual transformation. The engine block is split, revealing the internal carnage. Rust flakes fall like red snow. The connecting rods show pitting. The transmission gears have surface rust on their teeth. The carburetor is a solid block of corrosion. The aluminum body has literally reacted with the salt to form a white, powdery aluminum oxide that has expanded and cracked the housing. Anticipation. The wiring loom disintegrates at a touch. Its insulation turned green dust by copper corrosion. The ignition points are welded shut. The list of needed parts grows. Pistons, cylinders, crankshaft bearings, camshaft, lifters, primary chain, clutch plates, and every single seal and gasket. Haze trace. Metal resurrection. Shadow F parts baiting INUL tyrazonic cleaner problem. Surface rust is one thing. Pitting and structural corrosion are another. The salt has created microscopic pits that act as stress concentrators, weak points that could lead to catastrophic failure under load. Solution: every salvageable part undergoes a multi-stage cleaning process. First, they soak in a rust-converting solution that turns iron oxide into stable iron phosphate. Then, into the ultrasonic cleaner with a heated, alkaline solution that vibrates at 40 kHz to dissolve salt from deep within pores. For heavy rust, we use vapor honing with a water and glass bead mixture that removes corrosion without dimensional change or heat generation. The frame and swing arm are sent for powder coating, electrostatically applied polyester powder that bakes into a finished 5 times more corrosion-resistant than paint. For chrome parts beyond saving, we opt for ceramic coating on polished aluminum as a durable, salt-resistant alternative. Visual transformation. Parts emerge from their baths looking like new metal. The transformation is shocking. What was once a brown, crusty exhaust header now shows bare, pitted but clean metal, ready for coating. The engine cases, after hours in the ultrasonic cleaner, reveal their original casting marks and serial numbers. Anticipation. Now for the most expensive and technically demanding part: machining and sourcing rare OEM components. The cylinder walls may need to be bored oversize, requiring custom pistons. The crankshaft may need grinding to an undersize, requiring special bearings. Machining e component sourcing. Montage OF machine shop work problem. The cylinder heads have corroded valve seats and guides. The cylinders have taper and out of round beyond service limits. The crankshaft journals are pitted. Solution: the heads go to a machinist for new bronze valve guides and trace angle valve seat cutting. The cylinders are bored 0.30, oversized to clean metal, requiring matching forged pistons with moly-coated skirts. The crankshaft is reground 0.10, undersize on the main and rod journals. We source NOS new old stock timing gears and a camshaft from specialty suppliers. The carburetor is replaced entirely with a modern replica that includes improved materials resistant to ethanol fuel. The entire electrical system is replaced with a modern, sealed wiring harness using marine-grade tinned copper wire and waterproof connectors. Visual transformation. Precision machined components return from the shop with mirror-like finishes. The freshly ground crankshaft looks like jewelry. The bored cylinders have perfect cross-hatching for ring seating. Anticipation. Reassembly is where all this preparation meets reality. Clearances must be perfect. Lubrication critical. Rebuilding TATA hurt. TIMELAPSE engine reassembly with torque wrench problem. Rebuilding an engine with clearances measured in thousandths of an inch, using a mix of new and salvaged components. Solution: surgical cleanliness. The workbench is meticulously organized. Each component is cleaned again before installation. The crankshaft is installed with new main bearings coated in assembly lube. The connecting rods are torqued to exact specifications with a digital torque wrench that records each value. The pistons are installed with ring compressors, ensuring the moly rings aren't damaged. The cylinder heads receive new stainless steel valves with dual valve springs. Every fastener gets thread locker or anti-seize compound based on its application. The process takes 40 hours of focused work. Visual transformation. The clean, machined engine components come together like a precision puzzle. The fresh chrome plating on the rocker covers and powder coating on the engine cases create a stunning contrast. The engine, once a block of rust, now looks better than factory. Anticipation. The bottom end is together. The top end is complete. The timing is set. But will it have compression? Will it have oil pressure? PCs. Final assembly. ES systems check. Detailed shots of EHS system problem. Integrating all rebuilt systems. Engine, transmission, primary drive, electrical, fuel, brakes. Into a functioning motorcycle. Solution. The engine is mated to the freshly painted frame. The transmission is rebuilt with new seals and bearings. The primary drive receives a new chain and compensator sprocket. The clutch gets barnet plates and springs. The electrical system is painstakingly routed with cable ties and loom wrap, each connection sealed with dielectric grease. The fuel system uses an inline filter and ethanol-resistant hose. The brake system is completely rebuilt with new master cylinders, calipers, stainless lines, and sintered pads. Visual transformation. The motorcycle takes shape. What was a pile of rusted parts now resembles a motorcycle again, but cleaner and more detailed than it ever was from the factory. The attention to detail is evident in every routed wire, every aligned fastener. Anticipation. Systems testing begins. Electrical continuity checks. Fuel line pressure tests. Brake system bleeding. Each system must work perfectly before the first start attempt. Schliffhanger. Schloss on technicien's face. Hand on Eignitian switch at a moment of maximum tension. We've spent over 300 hours and a significant investment in parts and machining. We've fought every bolt, cleaned every crevice, measured every clearance. The new carburetor is mounted and primed. The electronic ignition system is set to 32 degrees advance. The rebuilt starter motor is connected. The oil tank is filled with braking oil. We've done everything by the book. All that work comes down to this one switch, this single moment where we learn if our diagnosis was correct, our machining precise, our assembly perfect. Herville. TAANG and cranks, Caxius, an der Rohrs TO life sound OF engine starting, initial cranking, fearing the starter engages. The engine turns over freely. Already a victory. It cranks, once, twice, then catches with a bark from the exhaust. It stumbles, then catches again. The technician blips the throttle, clearing its throat. The deep, lumpy idle of the ironhead fills the shop. That distinctive potato rhythm that Harley enthusiasts crave. It's not just running, it's healthy. No strange knocks from the bottom end. No smoke from the exhaust. Just clean combustion. The oil pressure gauge shows a solid 40 psi at idle. The mechanical symphony we've orchestrated is playing perfectly. Comparison. Esplite screen, montage of before bara after the visual evidence is overwhelming. Side-by-side comparisons tell the story better than words. The carburetor. From a solid, white-crusted block of aluminum oxide to a shiny, precision instrument delivering perfect fuel mixture. The wheels, once frozen solid on their axles, now spinning freely on new sealed bearings with fresh Dunlop tires. The electrical system. From a disintegrating bird's nest of green corrosion to a clean, labeled, waterproof harness with modern LED lighting. The exhaust system. From rusted-through mufflers with holes to ceramic-coated headers and chrome mufflers. The frame. From pitted, surface, rusted tubing to glossy black powder coat that's chemically bonded to the metal. The engine. From a sized, corroded paperweight to a gleaming, oil-tight power plant. Destrade e final adjustments. Bike OND. We NAMOMETER, then open road before hitting the road. We run the bike on a dynamometer to break in the engine properly under controlled load and to set the carburetor jetting precisely. We follow a strict braking procedure, varying RPMs, avoiding sustained high loads, and changing the oil after the first 20 miles. Then the real test, coastal roads. Not where it was abandoned, but where it can reclaim its territory. The bike pulls strongly through each gear. The transmission shifts smoothly. The clutch engages cleanly. The front fork with new seals and oil soaks up bumps. The rear shocks provide a plush ride. The brakes stop with confidence. Every system works in harmony. The motorcycle isn't just restored. It's been improved, hardened against its former enemy. Bike parked I in garage. Sunset like at streaming I and so. Can the saltwater murder of a classic Harley be undone? The answer is a costly, labor-intensive, but triumphant yes. It requires more than just mechanical skill. It demands chemical understanding, metallurgical knowledge, and systematic patience. This restoration wasn't about making it look new. It was about understanding and reversing a Quinzier chemical attack at the molecular level. We didn't just clean rust. We removed chloride ions from metal pores. We didn't just replace parts. We selected materials specifically for corrosion resistance. The 1978 Sportster that was left for dead has not only been brought back to life, but has been given a level of durability it never had from the factory. The powder coating will resist chips and moisture better than paint. The ceramic exhaust coating will withstand heat and corrosion. The marine-grade wiring will laugh at moisture. The stainless fasteners throughout won't seize again. This motorcycle now carries 2 stories. its original life as a 1970 segundos American muscle bike, and its second life as a triumph over one of nature's most destructive forces. It survived its own death, and in doing so, became something more interesting than a perfect restoration. It became a testament to what's possible when you refuse to accept corrosion's final verdict. The murder has been undone, and the evidence is in every perfectly torqued bolt, every clean oil passage, and every thunderous combustion cycle. What murdered machine should we attempt to save next? The challenge isn't finding them. They're everywhere, waiting for someone who sees not what they are, but what they could be again.